Hi students, today I am sharing with you solution of question number 3 of exercise 6.2. The figure is given in which AB is given parallel to CD and your EF is given perpendicular to CD again. This angle GED, you can mark this angle GED is this whole angle is given equal to 126 degree. On behalf of this information, you need to calculate the value of AGE, that is this angle. Then GEF, suppose I'm writing X, the value of X, and FGE, that is Y. So now, suppose here I have written angle 1. I need to determine angle 1, then the value of X and the value of Y. So I hope now you are very clear with the concept of your parallel lines as well as your lines and angles, mainly the property of your exterior sum angle property of triangle as well triangle angle sum property, or the other properties related to your parallel lines. So these are direct applications. Somewhere you can see here as AB is parallel to CD and this angle GED. Please draw the rough sketch somewhere and make it very clear where you are getting this angle GED is. The GED is this because this line AB is parallel to CD. Somewhere you can find as this the transversal here and angle 1 is lying to the alternate of GED. So no problem should be there to answer straightway that this is a pair of interior alternate angles. On behalf of this, I can write the answer for this is equal to 126 degree. Now come to the second point, that is your X. You see here X in the figure, somewhere it is lying here, that is in the triangle here, and this whole angle is given equal to 126. So you can note here X plus 90 degree is equal to 126. Am I clear to you? This whole angle given to you GED is 126, but this is the combination of these two, as this line is perpendicular to this, so this is 90 plus X will be equal to 126. From here you will be getting the value of X, that is 126 minus 90 is equal to 36. So second answer will be your 36 degree, and then 36 plus 90, as you know these are the alternate angles, and plus Y, or you can go for the linear pair, many options are there, that is 36 plus Y plus 90 is equal to 180, and then you can calculate the value of Y also comfortably. So that's all about your question number 3. Try it. If any difficulty will be there, we will be sharing when we will meet inside the class. Then question number 4, very interesting question. But you see one thing, that in your NCERT one hint is given that draw a line parallel through R either to PQ or to ST. But remember, during your examinations or any other class test, hints are not given, so you have to try at your own level. Do not forget the concept what we are studying, and here the given is PQ is parallel to ST, and here this angle PQR somewhere is 110 and RST is given 130, and I need to calculate this angle QRS. So nothing to worry. Again we are back to the concept of lines and angles or the properties of parallel lines. As per my experience, what you can do is straight away you can start, because I told ki any line can be projected infinitely in any of the direction. So both of these you can produce to any of the direction. To understand the concept of parallel lines is very clear within this figure. As you extend this PQ in this direction or TS in this direction, what happens, I'm getting a triangle over here in which one angle which I need to calculate is missing. And if I calculate these two angles, so very comfortably you see, if this is a straight line you have produced directly, so this I will be getting is equal to 70 degree. And here, as PQ is given parallel to ST, remember whatever is given to me, I have to make use of that. So if PQ is parallel to ST, then extended part of PQ will also be parallel to TS extended part. So then these two are parallel, and here I am getting these two are the cointerior angles. So you know the sum of cointerior angles is 180 degree, so this will be equal to what, 50 degree. And and then you are getting a pair of vertically opposite angle. You can mark this angle 50 degree. This is 7, this is 50, and this is R angle. So in triangle, the sum of the angles is equal to what? 180 degree. 70 plus 50 is 120, and then third angle will be equal to 60 degree will be the answer. So just try to apply your own understanding, whatever you have learned from the previous question and the properties, so that you just can get the solution of such problems comfortably. Now straightway I'll come to question number 6 of same exercise to you, that is 6.2. that is somewhere is the numerical from physics, but is asked in your this exercise. Here are the plane mirrors given to you, kept parallel to each other, and then you see in your question it is mentioned that PQ and RS are the two PQ and RS are the two plane mirrors kept parallel to each other. A ray incident strikes this mirror somewhere at B and then is getting reflected from this mirror to this mirror and strikes here at C and then again getting reflected this way, that is in the direction of C to D. So here it is incident from A to B, then from B to C, and then from C to D. This is the information given to you. AB strikes the mirror PQ at B, and then reflected ray moves along path BC and strikes the mirror RS at C somewhere, and again reflects back CD. You need to prove that these two rays AB and CD are parallel to each other. So that is, I need to prove AB is parallel to CD. Very interesting question mathematically. If you are clear with the concept of parallel lines, to prove two parallel lines, I have three options available with me. Either the pair of corresponding angles I need to prove equal, or a pair of alternate angles I need to prove equal. And the third option always is sum of co-interior angles is 180 degree. But what do I feel here comfortably? If you see the angles lying between these two rays, that is AB and CD, I am finding this angle ABC as well as this angle BCD. If I can prove these two angles equal, don't you think that these will be the pair of interior alternate angles? And on behalf of that property of the interior alternate angles converse, I'll be right finally AB is parallel to CD. So that's all geometry what I will be using here. But before that, as the mirrors are kept and the rays are falling on each other, it's like from this way to this mirror and from this way to this mirror. So this is a numerical from physics, that is from the chapter of light. Laws of incident. Angle of incidence is always equal to angle of reflection. So laws of reflection are there. You need to draw, if any mirror is there, any line is incident, this is called the normal. What is this called? Normal. And always remember, normal is always perpendicular to the surface of the mirror, because for any ray to form the angle we need a surface there, and this normal is acting as a surface to form the angle of incidence, that is angle I. And similarly, when it strikes at B, from B the ray is reflecting in this direction, so then this will be the angle of reflection, that is R. So as per the laws, angle I is always equal to angle R, so I will be able to write angle 1 is equal to angle 2, and the same procedure is here. This will be the angle I and this will be the angle R. Suppose I am saying angle 3 is equal to angle 4. So now angle 1 is equal to angle 2, angle 3 is equal to angle 4, and I told these are the normals, and normals are always perpendicular to the mirrors. Remember this. So I write BN and CM are the normals. Now look at this. What I need to prove is AB is parallel to CD, and I told somewhere I will be keeping my focus to prove this whole angle, that is I plus R is equal to this angle I plus R. So what I'll do now, as I said, BN and CM are perpendicular to these two mirrors respectively. So don't you think that this BN, now can I say ki BN is parallel to CM? If BN is parallel to CM, because this is also 90, this is 90, this is 90, so co-interior or any other property you can use here to prove these lines parallel, as three options are available with you. So this implies angle 2 is equal to angle 3. Why? Because pair of alternate angles. If this is parallel to this, so angle 2 is equal to angle 3. You can write alternate angles, and then you can say twice of angle 2. If two things are equal, then their doubles are also equal, will be equal to twice of angle 3. So I can split it like angle 2 plus angle 2 and then angle 3 plus angle 3. But 2 you said is equal to 1. So I write 1 plus 2, and 3 you said is equal to 4. So I'll say 3 plus 4, because angle 1 is equal to angle 2 and angle 3 is equal to angle 4. That is physics I am applying here. Angle of incidence is always equal to angle of reflection. On behalf of that, your 1 plus 2 is your angle ABC, and 3 plus 4 is equal to your angle BCD, which is a pair of alternate angles, which is a pair of alternate angles. Hence, by the converse, you can say AB is parallel to CD. So that's all about your solution of question number 6 of exercise 6.2. Please keep a check, see the reasons and mention the reasons very clearly. And tomorrow I'll be giving you a small test based upon your Euclid geometry as well this exercise 6.1 and 6.2. Please be prepared. Till then, thank you. Bye bye.